Powder bed fusion.
SLS,
SAF.
vapor smoothing.
Expo. Hello everyone. Welcome to the podcast called Expo. We will talk here about 3D technologies today with Jan Galko. And today's topic is powder bed fusion technology, particularly technology SAF and SLS. Can you maybe start with your historic lesson?
Sure. It's very popular, so let's start with that. So, as we discussed in previous episodes, 3D, pretty much all the 3D technology starts in 1980s. So SLS is first recorded or first approved powder bed fusion technology. So let's start with that. Name connected to SLS, which is selective laser sintering, is Carl Descartes. And at the beginning of 1980s, he was a professor at university, and he had idea for this technology, and he developed it during his time there, essentially. After several years of trial and error, he finally had a working machine, working prototype, and he applied for patent in 1986. So historically, it's the second 3D printing technology that we have. What's interesting about his story maybe is that he started a company, Desktop Manufacturing, which was in 2001 acquired by another company, 3D Systems, which is in turn the company that Chuck Hall started. So how does this technologies work? Like all the powder bed technologies have one thing in common: it's powder. So what's happening in these technologies is that the layer of powder is somehow applied to the printing substrate. Usually it's in a form of roller, or it can be some sort of wiper. Simply you will simply create a layer of powder, which is your one layer of print. And now the way to process that powder can be different, and so we have terms like SLM, SLS, SAF. And what's different there is different ways of sintering this or making this powder into solid. So SLS is laser sintering. You will have laser that will essentially stipple your layer, which means create it dot by dot. Or you can have something like electron beam to do this, or you can use the piezoelectric heads, similar like you would have in ink printer at home.
So what is this technology used for?
So as all the 3D printing technologies, it was conceived for prototyping, but slowly it's developing into something else. Because of its specifics, it's starting to be more used for small scale productions. And how it works, like every printing technology needs some sort of post-processing methods, and the powder bed fusion is you are most capable of streamlining the post-processing of powder bed fusion technologies. How? Simply, powder bed fusion prints into the powder, so the powder, not sinter powder in the cake, is actually your support. So what you get from the printer is usually cake, which is cube or rectangle of mass. You will take it out, and now you remove the not sintered powder. So you remove that usually with air pistol or somehow mechanically. You can use brushes or whatever. and then you can either do it manually, or you can use post-processing technologies designed for large scale volumes, let's say, like Dimension, or I think Formlabs has its own solution, and other companies will have their own solution. So what happens is, with these technologies, that you have device that will have drum that rotates usually, and you throw your prints in there, and then air and some medium, being it either glass or it can be some plastic, let's say, little plastic balls, will be sprayed at these parts as they rotate in the drum, and they, with time, and because they change position and they rotate and all of that, you will get them cleaned from all sides essentially. So that's why we use these technologies mainly, because if you are supposed to do this manually, which you can, but if you want to do 3,000 parts manually and you're using, let's say, glass can actually burn your parts. So you would have differently burned parts, and you couldn't guarantee your stability of process, or visual aspect of the print would be somewhat damaged, let's say. So with these post-processing, there are other steps that you can take. There are other methods that you can take. Usually what we do after this, because the powder bed technologies have rough surface, we will usually smooth it somehow. And again, this can be done similarly as cleaning. Mechanically, you will blast it with medium plastic now that will seal a surface somewhat. Or you can do this chemically, which is vapor smoothing, and basically you create vapor of maybe alcohol, maybe some other substance that will dissolve the surface a little bit and melt it together more, and the surface is then shinier, it's smoother, and it can have even some physical properties can be adjusted. So what I mean by that is, when you have vapor smoothed parts, they can be made watertight or waterproof by this process. So that's pretty much. And then you can also paint the parts either with usual methods, spray paint or whatever, or there are some also other methods where you put your dye into a water tank, you heat it up, and basically what happens there, the dye will be sucked into this material or this object.
Let's look at the difference between SLS and SAF. Let's talk about SAF now. Can you describe the history?
So SAF, okay. SAF technology is, again, powder bed fusion technology, created or conceived by Professor Neil Hopkinson. And what Neil thought about was some limitations of SLS technology, and he thought about, like, how do we make this process more streamlined, more professional. SLS has some limitations, mainly like every 3D printing technology has this limitation. It's warping. Essentially, if you have a large mass of any plastic or even metal, if we will talk about it later, when you sinter it or when you build your parts, it can deform. It can, as it cools down, it can contract and change shape and stuff like that. So every technology has that, some more, some less. But for powder bed, on the large objects, this is quite obvious. as it cools down. Every powder bed technology needs to be cooled down for several hours before you can take it out from the cake and use it. So Neil was focused on these problems and how to make it better, how to make it cheaper, faster, and all that. And what he thought about was like, okay, so let's not use a laser, let's use print heads. And what he did was he decided that the print head will again stipple the layer, but it will be jetted from the piezoelectric heads. So it's essentially again the process you would use in ink printer. Like the whole page or whole layer is sprayed by these heads, and then it is sintered by infrared lamps, which have like 400, 500 degrees of Celsius, where they bake the powder together essentially. And this is how the object is created. And what this technology does, it somewhat limits warping compared to SLS, but it's also very scalable. So laser technology, you have laser doing your dots, and yes, you can add lasers. Obviously, you have printers which will have 4 lasers synchronized. You have printers that will have 16 lasers synchronized, and do this on large area. But what SAF is offering you, you can essentially get a constant layer time. So if I want to do the same area with SAF, I will just use more heads in line. Basically, I will make the line bigger with instead of 3 heads, I will use 6 heads or 10 heads, and I can do the same. I can do 3 times or 4 times bigger area in the same time. So it's scalable, and it's meant for. Especially SAF is meant for small scale production, let's say up to 10,000 parts. So it can actually aid injection molding creation process or complete it somehow for small batches up to 10,000 pieces, let's say.
So how much do these technologies cost?
Well, again, you have your range, and some customers might be familiar with some small scale SLS printers like Sinterit or Formlabs will be making SLS printers that are relatively cheap, roughly 40,000 euros. Generally, of course, it will depend on your location and your reseller. And SAF is more expensive, and it's because it's meant to be a large scale or larger scale or larger volume production system. It's for companies. Obviously, it's not something you would have in your garage. You can if you have like spare 300,000 euros. So it's relatively expensive for everyday user, but it's meant for it was always meant for companies. And with these technologies, you also have to take into consideration your workplace, because you work with open powder in most of them, and powder at certain pressures and certain amount will be explosive. Any powder will be, but this needs to be taken into consideration when you build your operation room. It needs to have, let's say, special sockets, special vacuum, and stuff like that. So it further increases costs on that.
Okay, thank you for your answers.
You're welcome. Anytime.
And see you next time. Bye.
See you next time. Bye. Jak sa povie vrstva po anglicky? Layer. Very good. So This is how it works.
Yeah, well, you don't need me here anymore because you say everything. So.
You don't listen to me. Why am I even trying?
Let's go.
Okay. So ask the question. Ask the question.
What is this technology used for? Klapka.
I don't really know.
Doctor, historian Galko.
Dr. History. Historian. Archaeologist. Dr. Jackson. I mean Galko. No, uvidíš pri strihaní. Tu sa smieš, toto sa nedá použiť. Čo myslíš? To je to tvoj podcast. Tak veliť, to tomu nikto nevelí, to sa všetko sa improvizuje.